Hello and welcome to Data Analysis with Pandas course, one of the most in-demand skill required to become a data analyst or data scientist. I am Prithvi Raja, having more than 6+ years of training and teaching experience from technical institutes. Training and teaching is my passion, and I will be the instructor for this course. Before diving into the course, let us have a look at the data analysis. The most interesting thing is 80% of the time is spent on collecting, reorganizing, and pre-processing the data, and remaining 20% of the time is spent to visualize and take decision-making actions further. Why data analysis with Pandas? Python is a very good at data munging and preparation. Hence, Python provides a very powerful tool called Pandas for data analysis. What is data analysis then? The simple definition gives more meaning, that is, extracting meaningful insight from all the data available. Because data collection and generation is growing continuously in an exponential rate. All the major companies like Google, Amazon, Facebook, Netflix are analyzing this data and serving the people and other small scale companies based on the people activities and their interest. This information will be stored and used for further analysis and comparison of data in future. This course covers Pandas data structures, essential functionalities, data handling, data pre-processing, data wrangling, data grouping, data aggregation, pivoting, working with hierarchical indexing, converting data types, time series analysis, along with the advanced Pandas, features, and much more. This course is designed for business and data analysts, students, and other professionals who are eager to learn a more powerful tool for data analysis, data scientists and statisticians, any curious learner to update their knowledge in business analysis. So, are you excited to learn the Pandas? I will be happy to share my knowledge and work with you in this course. I look forward to seeing you in the course. Thank you. Before start working with the Pandas, let us see the brief introduction about it. Pandas is built on the top of Python language. It is an open source language and it is BSD licensed. It is a high performing data analysis library. It provides flexible and expressive data structures designed especially to work with the relational and labeled data. It is considered to be the fundamental building block for doing real-world data analysis. Pandas supports different kinds of data formats. Some of the important varieties are tabular data, ordered and unordered time series data, arbitrary matrix data, and any other form of observational or statistical data sets. There are two important data structures the Pandas to work with: series and data frame. Series is one-dimensional data which is of NumPy array type, whereas data frame is a two-dimensional labeled data which looks like a tabular data. Pandas is best for working with missing data, data size mutability, data alignment, grouping of data, and it is very much easy to convert Python and NumPy data structures into data frame objects. It also helps in reshaping and pivoting the datasets efficiently. It is a powerful tool nowadays to work with the time series data. Before Pandas, the data munching and preparation was done by Python, and data analysis and modeling with R language, and the result is used further by the Python to proceed further. But with the help of Pandas, the entire process is almost all replaced by Pandas, and it looks like only the forward direction process because Pandas is a Python toolkit. In this tutorial, we are learning in three stages. In first stage, we will be working with the basic building blocks like series, data frame, and index objects. And in next stage, we are set to work on pre-processing the data. And finally, in the third stage, we are ready to analyze and do practice with the real life data available. So, it is my pleasure to thank and welcome you for this course. Let us dive into the course now. Hi, welcome again. Let us see the solution for the practice part 1 on data structures. Here, the first exercise is create a series of objects using NumPy's linear space and random functions. Let us import the pandas and NumPy. Here, the linear space method will create a number of values between the start and stop values. By default, it creates a 50 values between the start and stop along the row axis. Let us create an array of elements between the start and stop values, that is, between the 1 and 10, by keeping the parameters to their default levels. Here is the array of elements between 1 to 10, but I have read only the first 10 values. Let us use these array of elements to create a Pandas series inside the series constructor. We got a series of type float. Let us change the third parameter, that is number, to a 5 instead of 50 and create an array of elements. Let us pass these samples to the Pandas series constructor to create a series. In order to construct a series from the random values, we can use NumPy's random function. Here, the NumPy's random.rand creates a random values in a given shape. If we pass only the single value, it creates an array of elements with the shape one dimension. Let us pass the single value to a rand function. We got an array of elements with the shape one dimension. Let us pass these array of elements to the Pandas series constructor to create a series. Here we got the series of type float. Let us move on to the next question, that is, create a series using a list of elements. Here I have some list of elements from 1 to 10. Let us pass these list of elements inside the series constructor to create a Pandas series. We got a series of elements of type integer. Let us move on to the third exercise, that is, for the data given below, get the index and values after forming a series object. Here is the data, that is India, New Delhi, Japan, Tokyo, UK, London. Let us extract this data and pass this data, that is a dictionary of data, to the series constructor to create a Pandas series. Here you can see the series object as an explicitly defined index labels, that is India, Japan and UK, and the values are New Delhi, Tokyo, London. Let us extract the explicitly defined index labels using the index attribute and the values with the values attribute. Let us move on to the fourth exercise, that is, create a series using a range of 10 values and specify the index explicitly. Use capital alphabets to index explicitly. Here we can use the numpy's a range method to create a range of 10 values. So here I am using a range method and passing the integer value 10 and creating an array of elements. Let us create an explicitly defined index labels with the capital letters from A to J. After creating a list of index labels, let us pass the array of elements, that is values, and the explicitly defined index values inside the Pandas series constructor to construct a series object. Here we got the series with the explicitly defined index labels from A to J and the array of elements from 0 to 9. Let us move on to the fifth exercise. For the exercise 4, find the shape and size of the series created. Here the series consists of explicitly defined labels from A to J, and the size of the series is from 0 to 9, that is 10. We can get the size and shape of the series using the shape attribute and the size attribute respectively. Let us use the shape attribute first. We got the one-dimensional shape, that is 10, that is 10 rows, and the size attribute to get the number of values in a series. Here we have 10 values. Let us move on to the sixth exercise, that is, slice the values of series created for exercise 4, that is, slice from 4th index up to the end with step size 3. Slice the entire series in reverse order. Slice the entire series with a step size 2. Here we know that if we use the single colon with the left integer value, it will slice the entire elements from that integer up to the end of the series elements. If we use the colon with the right integer value, it will slice from the 0 up to that integer value. So, if we use double colon with the left integer and the right integer, it will slice from the left integer with the step size as the right integer. Here we need to slice from the fourth index up to the end with the step size 3. So let us use the left integer value as 4 and the right integer value as 3 within the square bracket and with the double colon. In order to slice the values in the reverse order, we can use -1 after the step index notation, that is double colon. Here we got the series with the reverse order. Let us slice the values from 0 up to the end with the step size 2. So here I am passing no value at the left side and the integer value 2 on the right side with the double colon inside the square bracket. Let us move on to the 7th exercise, that is, convert the series object values created for exercise 4 back into the list of values. Let us check the type of the series before converting it to a list. Here the series is of class Pandas series. We can convert this Pandas series values into a list of values using the toList method. Let us use the toList method on the series. Let us check the type of the values converted using the type method. Here we got the type class list. Let us move on to the 8th exercise, that is, for the data given below, construct a series and add the data 500, 600 and 700, that means a list of values, to the existing series. Here is the data. Let us extract this data and create a series. Now let us extract the data to add and create a series. After creating a two series objects, we can combine these two series objects using the append method. The append method will append the new series to the existing series. So let us append the second series with the first series. So now we have successfully added the values 500, 600 and 700 to the existing series. Let us move on to the 9th exercise. That is, for the series created in exercise 8, get the subset of series for the condition given below. The condition is values greater than or equal to 100. So let us display the series first. But if you look at the series, it is of type object. So before using the integer conditional statement, Let us convert this series into a numeric type using to_numeric method. That is pd dot to_numeric, and inside the parentheses pass the series. So now you can see that the type of the series is of type integer. Now let us use the condition, that is the series and then the conditional symbols greater than or equal to 100. Let us keep this conditional statement inside the parenthesis, that is open and closed parenthesis, and pass this condition onto the series and create a new series with this condition. We got the new series with the values greater than or equal to 100. Let us move on to the 10th exercise. That is, for the data given below, construct a Pandas DataFrame object. Use labels data to set the index of the data frame. After creating the data frame, display the summary of the basic information. Here is the data and here is the labels data. Let us extract this data here and then pass the data and then labels to the index parameter to set as an index of the data frame object explicitly. Here you can see that the data frame consists of the explicitly defined row index labels. Let us use the info method on this data frame to get the basic information about the data frame object. The basic information says that it has total 10 entries, that is 10 rows from A to Z, and the column score is of type float with the 2 missing values, and the column attempts is of type integer, and the column qualifier is of type object, and the column name is also of type object. The data types displays it has one column of type float and one column of type integer and two columns of type objects, and also the memory usage, that is 400 plus bytes. Let us move on to the 11th exercise. Find the names of the people who have scored greater than 12 in exercise 10. Separate the people with the score and without any score for the exercise 10. Since we have used the explicitly defined index labels to create the Pandas data frame object in the exercise 10, so here we need to use the log indexer to filter the data frame object. So let us create a condition with greater than 12, that is on the column score. Let us pass this condition onto the data frame with the log indexer. Here we got the new data frame with the score column greater than the values 12. In order to separate the names with and without any score, we can use the not null and is null methods on the column score. So let us use the not null method on the score and create the condition. Let us pass this condition onto the data frame object. Here we got the data frame with all the non-null values on the column score. Let us use the isNull method on the column score and create the condition. Let us pass this condition onto the data frame. Here we got the data frame with the null values on the column score. Let us move on to the 12th exercise, that is, find the participants who qualify the test and who didn't qualify the test in exercise 10. Let us display the data frame once again. Here we can see that the column has yes and no data elements with lowercase letters. So let us use the column qualify with the condition equal to yes. So let us create the condition with the yes statement inside the parenthesis. Let us pass this condition onto the DataFrame object with the lock indexer. We got the DataFrame only with the yes statements on the column qualify. Let us use the another condition with the no statement on the column qualify. Here we got the data frame with the no statement with the column qualified. Let us move on to the 13th exercise, that is, for the exercise 10, separate the columns without score and form a separate data frame. Here we can use two methods. Either we can drop the column score or we can extract the list of column labels except the score column. Here I am using the second method, that is extracting the list of columns except the column score and then passing these lists onto the data frame object. Here we got the data frame without the column score. Let us move on to the 14th exercise. For the exercise 10, find the number of participants with the first attempt. Let us extract the column attempts first. Here, the column consists of the first, second and third attempts. Let us use the value underscore counts method on this extracted column. Here we can see that we have 4 participants with the attempts 1, 3 participants with the attempts 2 and 3 participants with the attempt 2. We can also get the number of participants whose attempt is first using the logical condition, that is, set the condition on the column attempts which is equal to 1 and use this condition onto the data frame object using the lock indexer. So once again we got the number of participants as 4 with the attempts 1. Let us move on to the last question. For the exercise 10, separate the column score and find the top score. Let us extract the column score first. We can use max attribute on this extracted column or series to get the maximum score. Here we got the maximum score, that is 30. Hi, welcome again. In this section, we are going to learn how data wrangling is performed and data which is not arranged and labeled correctly as per our requirement. In this section, we start with hierarchical indexing and end with pivoting the data. All methods of data wrangling here can be grouped into three main categories. They are join, combine, and reshape. Let us start with the hierarchical indexing. It is an important feature of Pandas that helps us to have multiple index levels on an index. This helps us to work with higher dimensional data in a lower dimensional form. Let us create a simple series with the list of lists as its index. When we use a multiple list to create an index, the resulting index will be the hierarchical index with the index levels maintained. The index of the series can be found using index method on series. When we assess the index, it shows that the index used is of multi-index multiple levels. Here, the second level shows that the integer position assigned for the string labels and the actual integer position of integer labels when they are hierarchically indexed in a multi-index. If I want to assess the data with respect to a specific index labels, that is possible and is known as partial indexing. Here, I would like to assess the data associated with the index label A. I got the data associated with the index label A. We can also slice to get the data associated with the index labels. Say for example from A to C. To select a partial index, we can pass a list of index labels to be selected inside the indexing object. Say for example A and C. We can also use explicit index method to load the series objects. Here, I would like to assess the first data of each hierarchically indexed labels using the explicit log. We can easily rearrange the hierarchical data into a DataFrame object using unstack method. Unstack is also known as pivot series with multi-index to produce DataFrame, and the level involved will automatically get sorted. Let us see the docstring of the unstack. It uses level is equal to -1 by default and fill underscore value is equal to none by default. The level is an integer or string or list of these. Default last level. Fill underscore value. It accepts scalar value. By default none. That means the value to use when replacing the nan values. Let us keep this information in a separate window. Let us use the unstack method on multi-index series created just now. Here, the missing values are filled with nan by default, as fill underscore value is equal to none by default. We can replace the missing values using fill underscore value parameter inside the unstack method. Here using 0 for the nan values. Notice that the nan values have been replaced successfully by 0. unstacked series can be stacked back using the stack. Here I would like to stack back to the unstacked series using the stack method. I got the series with multi-index levels. Two-dimensional data frame, on the other hand, can have multi-index in either of its axes. In the data frame, the name index refers to the row index by default. Let us create a simple data frame with multi-index on its row index as well as on column index. In the data frame, we can observe that the multi-level on column index has two column names, green and red under the column index level 1. We can easily rename the row and column index names with the help of DataFrame.index names and DataFrame.index.columns attributes. Here, I would like to change the row index level names with the value 1 and value 2. And the column index level names with the number and color. Let us display the data frame, how it looks. Now easily apply partial indexing on data frame similar to like series. I would like to access the column index label 1, which is the column index first label name. Now we can re-index with the hierarchical indexing for the series and data frame objects. To combine and merge datasets, Pandas provides different methods. They are merge, concat, and combine first. Let us see how merge works. The docstring says that it merges the data frame or named series objects with a database style join. The join is done on columns or indexes. It accepts the parameters right how is equal to inner, on is equal to none by default, left on, none, right on is equal to none, left underscore index is equal to false by default, right underscore index is equal to false, sort is equal to false. It also accepts suffixes. Right, the parameter, the data frame or named series object to merge with. That means the first data frame object and the second data frame object. Here the first data frame object will be considered as the left and the second data frame object will be considered as the right. How? Whether left, right, outer or inner. Default inner. Type of merge to be performed. Similar to like inner join, outer join, left join or right join. Left use only keys from left frame similar to a SQL left outer join. Right use only keys from right frame similar to a SQL right outer join. Outer use union of keys from both the frames. Inner use intersection of keys from both the frames. On label or list. column or index level names to join on. These must be found in both the DataFrame objects. If on is none and not merging on indexes, then this defaults to the intersection of the columns in both data frames. Left on, label or list or array like column or index level names to join on in the left data frame. Right on, column or index level names to join on in the right data frame. Similarly, the left underscore index, use the index from the left data frame as the join key. Right underscore index, use the index from the right data frame as the join key. And suffixes. Suffix to apply to overlapping column names in the left and right side, respectively. Here I am creating two simple data frames to work with these methods, data frame 1 and data frame 2. In both the data frames, key column is common, but the number of rows and values are different. The Pandas merge method offers different style to join the data frame objects as per the DataFrame. Here, I would like to use data base style first. This is referred as many to one join. Let us pause the two data frame objects inside the Pandas merge operation to merge them together. Notice that in data frame 1, B appears first and then A. Hence, the merge operation has considered the data frame 1 data values first and then it is matching with the data frame 2 values. If there is no common values in data frame objects, that values are excluded from the merge operation. Hence, we got only the B and A values that are common in both the data frame objects, with the values associated with the other columns remain same. And also, the important thing is the merge operation uses the overlapping column names as the merging key. Here the column name key is the merging key. Hence, we got the merged data frame object based on these columns in both the data frame objects. Let us use the Pandas style to merge the data frame objects. Once again, we got the same result. Just now we talked about the merge key. The merge method uses the overlapping column names as merging key by default. But we can also specify it explicitly, and it is a good practice always. So let us switch on the merge key using on parameter by passing the merge key column name. Here, the merge key column name itself is key in both the data frame objects. Suppose if the data frame columns names are different, we can use left on and right on parameters separately. Let us rename the columns key in both the DataFrame objects created earlier. Here I am using left key and then right key for the merging case. Now in DataFrame 1, the key column is now the left key, and in DataFrame 2, it is right key. Now let us merge these two DataFrame objects by switching on the left and right keys separately. That is, left on is equal to left key and then right on is equal to right key. When we switch on both the column names in both the DataFrame objects, these column names are considered as the merging keys. Here the left key and the right key. By default, the merge operation does an inner join. The keys in the result are the intersection or the common set found in both the tables. Here in the above merge operation, C and D data and associated values are missed. This type of join is known as inner join. It takes the intersection of the keys for the merging operation. Here, the common values for the left and right key are A and B. They are included, but C and D are excluded. Let us use how is equal to outer to do an outer join. It takes union of keys for the merging operation as per the docstring. Now we got the outer joined object with all the columns merged together and filling the missing values by the sentinel's nan. Notice that C and D appears only in left key and right key column respectively, and hence the non-overlapping values are filled with nan. Similarly, you can do left and right joins by yourself as a mini exercise. Just now we saw many to one merge operation. Let us see many to many merge operation. Here I am creating the two DataFrame objects to show how many to many merge operation works. In the DataFrame df_m1, D is not present, and in DataFrame df_m2, C is not present. And for the first DataFrame, I am using the merging key as first key, and for the second DataFrame, I am using the merge key as second key. And I am using the different column names data1 and data2 for the DataFrame 1 and DataFrame 2 respectively. Now I would like to merge these two data frames by switching on the first key and then the second key of the first data frame and the second data frame objects respectively. Notice that there were 3 B rows in the left data frame, that is df underscore m1, and 2 B rows in right data frame, that is df underscore m2. Hence, after merge operation, we got the Cartesian product of these rows. Hence, the result as 6 B rows. 1, 2, 3, 4, 5, 6. That is nothing but the Cartesian product. This is the inner join. Let us perform the outer join by pausing how is equal to outer. The result is the union of all the rows, and the non-overlapping rows values are filled with nan sentinels. Let us see the left merge operation by pausing how is equal to left. The priority is given for the left data frame rows, and the corresponding data frame rows are matched with the right data frame. If the rows do not overlap, then they will be skipped from the merge. Hence, the D row in the right data frame has been excluded. Similarly, if we perform the right merge operation by pausing how is equal to right, the priority will be given to the rows of the right data frame object. Here in the result, the C row of the data frame object is excluded from the merge operation. This is all about many-to-many merge operation with a single column. Now we can work with the multiple column names as the merge keys. Here I am creating a 2 data frame objects to work with the multiple column names. They are data frame left and then data frame right. Both the data frames have key 1 and key 2 columns as the merging keys. When we are joining columns on columns, the indexes on the parsed data frame objects are discarded. Let us merge these 2 data frames with the 2 key columns, key 1 and key 2, as the merge keys. Here I am performing the outer join first. The resulting object has the union of the rows appear in both the columns key 1 and key 2 of both the data frame objects. Let us do the inner join by pausing how is equal to inner. Notice that it includes only the column rows and associated data values. Notice that the row index labels 0 and 2 are common in both the data frame objects, that is 0 and 2, Raga 1, Anuraga 1, Raga 1, Anuraga 1. That means how is equal to inner will consider the intersection of the merge key rows. If we do left join by pausing how is equal to left, the left data frame rows are given the primary priority. Similarly, if we pause how is equal to right, the right data frame rows are given the primary priority. If you observe the above operations, one thing we have noticed seriously is while merging, we may face problem with the overlapping column names. So, let us see the operation of merge by switching on only one column name, say for example key1. Notice that in order to assign values for key1 column, the key2 column has split into two columns with respect to the left data frame with key2 underscore x, and for the right data frame with key2 underscore y with their corresponding values. We can easily overcome this situation by using suffixes parameter as per the docstring, which is used to suffix a different key suffixes for different data frame objects. Here I am using underscore left and underscore right suffixes for left and right data frame columns. Notice that key2 underscore x have been replaced with key2 underscore left, and key2 underscore y has been replaced with key2 underscore right.